Today's lesson is on segments and their measurements. We'll be taking a look at different types of segments, finding their measures. First, we're going to take a look at some different definitions. We'll start with what is a postulate. A postulate is a rule in geometry that is accepted without having to show why or to prove it. We're going to talk a lot about postulates throughout the class. Theorem is a rule in geometry proven to be true. A rule in geometry, whether it's a postulate or theorem, are going to tell us about how we can learn different ideas in geometry class. Our first postulate that we have and learn is called the ruler postulate. It tells us how we can measure points on a line. This is what you normally learn in algebra classes. If you assign a coordinate on a line to a point, then take another point and do the same, you can find the distance between the 2 points. The definition of ruler postulate tells us that we can take the distance between 2 points, take the absolute value of the difference, and find the measures of the coordinates. This example shows us that we can simply count the number of spaces from A to B, and that will give us the length of the segment. The other thing that we can do to find the length of the segment is we can take and subtract the 2 measures, and once we subtract the 2 measures, then we can find the absolute value of 3 minus a negative 2 minus a negative becomes plus a positive. Our distance, as we can see by looking at it and by the calculation, is 5. Here we have just an example of some blind segments and measuring them on a ruler. Couple of notes: if you're starting from a point other than at the end of the ruler, and it's generally good to start at 1, not to start at the very end of the ruler when you're measuring for accuracy, we can then take the difference of the 2 measurements. This one, if I take a look at and line up where the 2 ends of the segment are on the ruler, I can then figure out a fairly accurate measurement, and this one is 6 centimeters. We can measure in metric or in our standard unit of measurement. The next thing we'll look at is the idea of between. We have to define in geometry what we mean by between. When you have points on a line, we would say one is between the other 2 points if they are collinear points. Again, collinear means on the same line. The first drawing, that would be the correct way to define between, not the second way. Next, we have what's called the segment addition postulate. Basically, it says how we add things together. If you take the length of one segment, add the length of another segment, you end up with the length of the whole segment. Now, if we're working with just numbers, it would seem fairly simple to solve. For example, if this length is 4, and the length from B to C is length of 12, then the entire length of the segment would be length of 16. Add them together. Same thing on the example, but this time we're going to use x's like we do from algebra class. We're going to use this to find out what the value of x is, and then we'll use that to find the missing lengths from L to M and the length of M to N. We already know what L to N's length is. When you're looking at this, when you see this segment without the marking drawn above it, that means we're going to find the length of the segment. If we take a look at the drawing, the length from L to M is 3x plus 8. The length from M to N equals 2x minus 5. And the length of the entire segment is 23. We can do the same idea as the previous example. Take the first 3x plus 8, add it to the second segment, that's this piece, 2x minus 5, and set it equal to the total length of our segment, which was 23. It always helps to put a drawing with the problem so you understand the problem better. Now we'll just do some basic algebra. Combine your x's together, like terms. 3x and 2x would equal 5x's. Combine your non-x terms together. 8 and negative 5 combined would equal a positive 3. Set that equal to the 23. Next, subtract 3 from both sides. Five x equals 20. Divide both sides by 5. X equals 4. Once you find x, we're using that in this problem to find the length of each segment. 3 times 4 plus 8 and 2 times 4 minus 5. We'll go back up to where we originally have the line segments and we'll plug in 4 for x. Now we can get the length of each segment. 3 times 4, 12 plus 8, 20. 2 times 4, 8 minus 5 would equal 3. The total, of course, should equal 23, and it does. Here's another example. This time there's no drawing, so the first thing we're going to have to do is to get a drawing. Just make a line segment on your paper. We know we're working with A to B and B to C and A to C. So we'll start by labeling the drawing. Put a point A. We're not sure where B is, so we'll just put a point somewhere here. B. And finally point C. Label the drawing. A to B is 7x plus 9. B to C is 3x plus 4. And A to C is 143. Set up our equation. 7x plus 9, that's the first piece, added to the second piece, plus 3x plus 4 equals the total length of the segment, 143. Let's do our algebra again. 7x plus 3x equals 10x. 9 plus 4 equals 13. We leave the 143 on the right side. Subtract 13 from both sides to get the 10x by itself on the left. We now have 10x equals 130. Divide both sides by 10. X equals 13. Next, we can go back and do the math. Put in 13 for x into both of our lengths that we need to find. So again, we'll do the math and figure out what the lengths of each of the segments are that we're missing. 3 times 13, which would give us 39, plus 4, which is 43. 7 times 13, which would be 91, plus 9 is 100. And the two segments together equal 143. When you first do your drawing, notice that they are not going to be drawn to scale. Oftentimes in geometry, a lot of your figures that you see on drawings or in examples are not going to always be drawn to scale. Keep that in mind when you're doing problems. The next thing we'll look at is the distance formula. The distance formula is based on knowing some points on a graph. This is if we need to find the length of a segment on a two-dimensional coordinate graph. We start with our points and label the first point x1 and y1. We would label our second point x2 and y2, and then we'll use this formula, which is really just a version of another formula that we'll look at later on, to help us to figure out the length of the segment. Here's the actual drawing. We want to find the distance from A to B right here. We'll label this x1, y1. The 1 just indicates its position, first and second. That's all the numbers mean for the little subscripts. This will be called x2 and y2. That will be our second coordinate point for what we need. Now we'll do our solving. We're going to find the length from A to B. We're going to simply plug the numbers where they go into the distance formula. Take the second x, which is 1, minus the first x, which is -3. We're going to square that, plus, take the second y, which is 2, minus the first y, which is 3, and square that. Now we'll simply do the math to solve it. Minus a negative will become plus a positive. 1 plus 3 is 4. 4 squared is 16. 2 minus 3 would equal -1. -1 squared is 1. 16 plus 1 is 17. We can leave it in square root form. If you prefer, you can use your calculators to figure out a decimal for the square root of 17. Our last example, we're looking at finding whether the segments are the same length. Another word for same length, as it shows at the bottom here, is congruent. Congruent means two or more segments that are equal in length. Notice that if we use the congruent symbol, here's the congruent symbol, we would put a segment mark above it. If we're just using the equal symbol, we don't put any segment marks above the segments. For our final example, we'll find the length and the distance between some of the segments. Example, I'll show you the distance from E to F, and we'll compare and see if that's the same distance or length as it is from F to G on the graph. 4 squared equals 16, plus 2 minus 3 is -1, squared is 1. We end up again like the same answer as last example, square root of 17. We can leave it in square root form, but let's compare that now, F to G. Call this x1 and y1. Call G x2 and y2. And set it up in the formula to solve it. -3 minus 1 and square it plus 0 minus 2 and square that. Negative 3 minus 1 equals negative 4 squared equals 16. Negative 2 squared equals positive 4. We get two different answers, which tells us that the lengths are not equal. So this concludes our lesson on segments and finding the lengths of segments.